Dear students of secondary certificate, now we are going to start the fifth episode, Geology, with Mr. Sabit. The physical properties of minerals. The most important duties of geologists to identify the minerals in the places of their existence. Geologist uses the apparent properties, the clear properties, to observe the hand specimen and to identify the mineral, and then to confirm that in the lab. And to use required devices and complex analysis. Here is a quick discussion of the most important and distinctive physical properties that can be classified into optical, cohesive, and magnetic properties. The optical properties. These properties depend on the interaction between the incident light on the mineral and the reflected light from itself. The most important optical properties are luster. Luster is the ability of the mineral to reflect light that's falling on its surface. The ability of the mineral to reflect light that's falling on its surface. There are two types of luster. Metallic luster. Some minerals show a metallic luster and resemble metals that reflect light so much the mineral is bright, brilliant, such as pyrite, galena, and gold. Non-metallic luster. This is another type of luster. Non-metallic luster. Minerals which have non-metallic luster are described as familiar examples to us, such as number one, vitreous, glassy, as in quartz and calcite, pearly, as in feldspar, adamantine luster, as in diamond, earthy luster or dull, the least luster, matte luster, as in kaolinite. So the non-metallic luster, vitreous like calcite and quartz, purely like feldspar, adamantine luster as in diamond, dull or earthy luster as kaolinite. These properties depend on interaction between incident light on the mineral and the reflected from its surface. The most common important properties. So, number one or number two after luster is color. Color of a mineral depends on the length of light waves reflected from its surface. Although color is the most obvious property of minerals, it may not be very useful for their identification because most of minerals change the color by changing its chemical composition or contain small portion of impurities may change the color of the same mineral. So color may not be very useful. In general, color of a mineral depends on the length of wavelengths or the length of light waves reflected from its surface. The color changes according to the amount of impurities or by changing the chemical composition. We take for an example quartz found in different colors. Rose quartz due to the presence of manganese impurities. Purple to violet quartz. Amethyst. So quartz is rose due to the presence of manganese impurities, and purple to violet as in amethyst due to the presence of impurities of iron oxides, or quartz may be milky, white like milk due to many gas bubbles. There are gas bubbles, or maybe smoky quartz or gray to black color due to breaking up some bonds when they are exposed to radiation from radioactive source. But the pure quartz is transparent and colorless and known as rock crystal. So the pure quartz, which has no impurities, known as rock crystal, and is colorless and clear. I mean transparent. We take another mineral which is sphalerite. Sphalerite is zinc sulfide. It has a yellow transparent color. Maybe changes into brownish color when small amounts of iron replace zinc in its atomic structure. So the pure sphalerite is yellow color. But if some impurities of iron replaces zinc, the color changes into brownish. But some minerals have a permanent and unchanging color, known as real or native color. So the native color for some minerals, some minerals have native colors and don't change, like the yellow color of sulfur and the green color of malachite, hydrous carbonate. Now we have another property. We have another physical property or optical property, which is streak. What is a streak? Streak is the color of the powder. The color of the powder taken from a mineral. It is the color of the powdered mineral. And we get it by scratching the mineral on a piece of unpolished porcelain. So the streak is the color of the powder of mineral. Streak has a constant color. Okay, streak has a constant color for minerals whose color changes due to changing type or quantity of impurities, and so it is one of the properties that can be relied upon to identify the minerals, such as hematite. Hematite, the mineral, has two colors, dark gray and red, while its streak is red. Pyrite, which is it characterized by golden color, its streak is black. And quartz, which has different colors, its streak is white only. So if we look at the streak is a constant color. I mean, the color of the powder of the mineral is constant. Hematite, as we said, has two colors, dark gray and red, but its streak is red. Pyrite has a golden color, but its streak is black. Quartz has different colors and its streak is white only. Let's take another property, play of colors. Some minerals change their color when moved in front of human eyes in different directions or in front of a light source. This property known as play of colors. Okay, and some minerals like precious and semi-precious gemstones, which we use in ornament, for example, diamond changes the color into red and violet when gives a strong luster in all directions. So when the source of light moves in front of a color or in front of a diamond, color changes from red to violet, red to violet, red to violet, and gives strong luster in all directions. Precious opal. This is a mineral characterized by spangling, or known as cat's eyes. So precious opal, characterized by cat's eyes, is also with a mineral luster. Okay, I mean, where mineral luster has fibrous tissues. Okay, and rippling depending on the direction of view. If you look here, we find that precious opal has eyes of cat or cat's eyes. And now another property is transparency. Transparency of a mineral is the transparency degree of the ability of light to pass through the mineral. So the ability of light to pass through the mineral, or how much light passes through a mineral, this is transparency. So according to the amount of light passes through a mineral, we have three types of transparency. Transparent mineral, that means most light passes through and we can see any picture behind it clear. Translucent mineral, some light passes through the mineral, but we cannot see the picture behind this mineral clear. And number 3, or the third type, is opaque mineral. The mineral is opaque if the mineral doesn't transmit light at all. If the mineral doesn't transmit light at all. So we have 3 types of transparency. Transparent mineral, most light passes through. Semi-transparent mineral, some light passes through, but we can see any picture clear behind the mineral. And third type is opaque mineral, which no light passes through, but the all light is reflected. And now we are going to the second type of properties, which is the cohesive properties. Cohesive properties, we will take hardness. Hardness of a mineral is its ability to resist scratching. So hardness is the resistance of scratching. It is determined relatively where a harder mineral will scratch a softer mineral. So it will be determined where harder mineral scratches a softer one. Hardness is determined numerically according to the Mohs scale. Mohs scale is which minerals are arranged from 1 to 10 in degree of hardness. The softest mineral, number 1 on the scale, is talc, while the diamond, which can scratch all other minerals, has a hardness of 10. So the mineral which has the number 1 in Mohs scale is talc. Number 2 is gypsum. Number 3 is calcite. Number 4 is fluorite. Number 5 is apatite. Number 6 is orthoclase. Number 7, quartz. Number 8, topaz. Number 9 is corundum, and number 10 is diamond. This is Mohs scale of hardness. Determination of hardness in the field or lab, or when the geologist go to the field to search for or to look for some kind of minerals. He's supposed to determine the hardness, because hardness is a very important property to distinguish a mineral. It is easy to determine hardness in the geological field or laboratory by using set of hardness pens that are made of alloys which have the same degrees of hardness identified in Mohs scale. If we use the fingernail, the hardness of the fingernail is 2.5. But if we use a copper coin, the hardness of the copper coin is 3.5. Window glass has a hardness of 5.5. Ceramic or plate of ceramic has a hardness of 6.5. So most minerals have hardness less than 6.5, which makes the determination of hardness relatively easy. As used hardness property to distinguish between natural and precious gemstones, which are expensive, and those manufactured artificially or imitation ornamental stones, which are made of glass material or aluminum oxide. I mean aluminum oxides. The most important gemstones and precious minerals, in addition to their attractive colors, they do not pin scratched easily. Therefore, most of them exceeding hardness of 7.5. So all precious or real gemstones, their hardness exceed 7.5 hardness in Mohs scale. While imitation ornamental stones are characterized by attractive colors, but their hardness are less than 6. So if we use a plate of ceramic to scratch a gemstone, and if the gemstone is scratched, this is not a real gemstone, it's artificially prepared. But if the hardness is more than 7, this is a real gemstone. Now we are going to take another property of cohesive properties, cleavage. Cleavage is the ability of a mineral to split along planar surfaces, representing the weaker planes produce smooth surfaces when minerals are broken or pressed. So the ability of the mineral to break up on planes which represent the weakness planes or the weakness of bonds, okay, or the weaker planes, and produce smooth surfaces or surfaces when minerals are broken or pressed. What are the types of cleavage? Types of cleavage may be the mineral cleavage P in one direction. So cleavage in one direction. The best example of cleavage, what is seen in mica mineral, which is characterized by good cohesive in one direction, which is known as flaky cleavage. So flaky cleavage, which is cleavage in one direction, is clear in mica mineral. And we know what are mica minerals. It is biotite mica and muscovite mica. It is splitting easily along one base plane, forming thin plates or sheets. So thin plates or sheets are flaky cleavage. What is clear in mica? We gonna take another example, graphite. Graphite also has good basic cleavage, where the cleavage is in a direction paralleled to the base of crystals. So we call this basic cleavage. And this is another type of cleavage in one direction, that is in graphite. Cleavage in more than one direction. Many minerals have cleavage in more than one direction, maybe in 2 or 3 directions. Halite, galena have perfect cubic cleavage. So halite and galena have a perfect cleavage or a perfect cubic cleavage. That means a cleavage in galena and halite in more than one direction. As we know, galena and halite has a cubic symmetrical crystal system. So the cleavage may be in 3 directions as in halite and galena. Calcite, on the other hand, has a rhombohedral cleavage. So calcite has a rhombohedral cleavage. But there are many minerals have no cleavage, like quartz. Fracture. Fracture is another cohesive property. Fracture is the shape of surface resulting from the breaking of a mineral or from breaking the mineral, and resulting shape of fracture does not follow any described plane of cleavage and compared to known forms such as conchoidal fracture. So, if we break mineral and we have a conchoidal fracture, some minerals are characterized with a conchoidal fracture, like quartz and flint. Quartz and flint, or chert. Chert, flint, or quartz are characterized by conchoidal fracture. Or rough fracture with uneven surface. So we have conchoidal fracture like quartz, flint, chert, and also uneven surface or zigzag fracture, uneven, with sharp elevations that characterize the majority of minerals in nature. So the majority of minerals in nature have uneven fracture. Malleability and ductility. Malleability and ductility feature reflects the possibility or the easiness of malleability or ductility of a mineral to form thinner sheet wires like gold, silver, or copper. So the ability of a mineral to make thinner sheet wires, this is a malleable or ductile mineral like gold, silver, and copper. But some other minerals are considered as brittle or breakable if they are fragmented by hammering. So if we hammer other minerals, these minerals will be brittle or breakable. So they are non-malleable or non-ductile. Some other properties like specific gravity. Specific gravity is a ratio between a mineral mass and a mass of the same volume of water. So specific gravity is a ratio between the mass of a mineral or a specific mass of a mineral and the same mass of the same specific volume of water. So specific gravity of a mineral are ranging between light, medium, and heavy, such as the specific gravity of galena is 7.5 and the specific gravity of gold is 19.3. So we should remember the numbers. Galena specific gravity is 7.5 and gold specific gravity is 19.3. Also another property is magnetic property. Magnetic properties in terms of the attraction to magnet, the attraction to magnet is the magnetic properties. As magnetite, hematite, they have magnetic properties, but not attracted to magnet like other minerals like gold and diamond. So some are attracted to magnet like magnetite and hematite, or not attracted to magnet like gold and diamond. Thermal properties, such as the ability of mineral fusion I mean the mineral to change into melt by raising its temperature to reach the melting point. Maybe the melting point is high, maybe the melting point is low. So the thermal properties is distinguishing properties to determine whether the mineral has a high melting point or a low melting point. Also, there are other properties to identify a mineral or to identifying a mineral. The taste, such as salty in halite or bitter or bitter, and also the touch and the smell. So there are other properties we can use like the taste, smell, and touch. Now we have finished our session today. I wish you all the best with geology with Mr. Sabbath. Thank you so much.